Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. Today we'll be solving paper 1A HL of time zone 3. So let's get started with the first question. Here to first find the number of oxygen atoms present in 0.02 moles of CuSO4.5H2. Let's find the moles of oxygen atom in 1 mole of CuSO4, right? So CuSO4.5H2, right? You have 4 oxygen here with sulfur, and you have 5 oxygen in 5H2. You have total 9 moles of oxygen in 1 mole of CuSO4. So next we'll find moles of oxygen in 0.0200 mole of CuSO4.5H2O. You just have to multiply 9 with 0.02. This is 0.18, right? And then you have to find the total number of oxygen atoms. The total atoms of oxygen. This will be moles times the Avogadro's number, right? Moles is 0.18. Avogadro's number would be 6.02 times 10 to the power of 23. When I simplify, I'll get 1.08 times 10 to the power of 23, which is option D. Let's move on to the next one. What is a possible empirical formula for the substance with molar, the molar mass of 58, right? Find the molar mass of C2H5. For C2H5, the molar mass of the empirical formula mass, right? 2 times 12 plus 5, which is 29, right? Now, if you divide 58 with 29, you get a whole number. So C2H5 possibly can be the empirical formula of a substance with MR58. Yeah, so that is fine. Now next is C4H10. Now we don't even have to find the molar mass of C4H8, C4H10, because C4H10 is not an empirical formula, it's a molecular formula. The empirical formula of C4H10 is C2H5, right? This cannot be the answer because it's not an empirical formula. Next C3H60, find the MR, 3 times 12 plus 6 times 1 plus 16, right? 36. So yeah, we exactly get 58 for part 3. So yeah, again, if you divide 58 with 58, we get 1, which is a whole number. So this can also be the empirical formula. Answer would be 1 and 3 only, which is option B. Next, which volume of butane gas will produce 40 centimeter cube of carbon dioxide gas when it's completely combusted in oxygen? So I need to find the volume of butane. I know the volume of CO2. So instead of moles, I can also use the volume ratio, right? So volume of CO2 by volume of C4H10, this will be equal to 8 over 2, which are the stoichiometric coefficients of CO2 and C4H10, right? It's better if we just take the reciprocal. That will help us with the calculations a bit. C4H10 divided by V of CO2, this will be 2 over 8. So V of C4H10, volume of CO2 is 40. This is 1 over 4. So V of C4H10, this will be 40 divided by 4, which is 10. And as the volume of carbon dioxide is in centimeter cube, this volume will also be in centimeter cube, right? So answer exactly matches with option B. Now moving on to this one. Now here people will have a lot of confusions because like some people think that the total relative abundance should be 100. It can be more than 100, right? So how do we find this? So if you draw a line here, you see this peak exactly corresponds to 100. So atomic mass, AR is 11 when percentage abundance is 100. And for AR10, we have to find the percentage abundance. So if I draw a line from here, so approximately it's 20, like if this is 10, this is 20, this is 30. It's approximately 22 or 23 approximately, right? So let's take the abundance as 23%. Fine. So PR would be abundance times the atomic mass, right? Divided by total abundance, which is 100 plus 23. So if I plug it in a calculator, I'll get 10.81, right? Which is approximately 10.8, and which corresponds to option C. Next, what is the maximum number of electrons that can occupy the fourth mean shell? The maximum number of electrons is given by this formula 2n squared. For fourth shell, n is equal to 4, so 2 times 4 squared, which is 32, option C. Next, what is the formula of compound formed by aluminium ions and sulfate 6 ions? Sulfate 6 is SO4 2 minus, because here the oxidation number of sulfur is plus 6. Aluminium is Al3 plus. Now we need a compound between this and this. So we can use the cross multiplication, or the cross method, to find the ionic compound. So bring the 3 here, bring the 2 here. You get Al2 SO4 whole thrice, which is option D. Next, a substance has the following properties, right? It has a high melting point, does not conduct electricity when solid, but conducts electricity when it's molten. So all of these properties hints that it's an ionic compound, right? If it's a metallic compound, compound will conduct electricity in solids and liquids both, right? So cannot be metallic. If it's simple molecular, your melting point will be low. If it's covalent network, yeah, other than graphite, so graphite conducts electricity even in a solid, right? So covalent network could also be not right. So from every direction, it's an ionic lattice. So ionic compounds have high melting points, right? They do not conduct electricity in solid because, like in solid, the ions would be fixed into its place. They cannot move and they cannot carry the charges. But when an ionic compound is molten, the charges or the ions can move, and hence they can carry the charges and conduct electricity. Now the next one, which mean force of attraction causes the boiling point of ammonia to be significantly higher than that of phosphine? Ammonia, NH3. So phosphine is a polar compound, right? So the mean intermolecular force of attraction in phosphine is dipole-dipole interaction. But in NH3, as hydrogen is directly bonded to nitrogen, this hydrogen can show hydrogen bonding. Okay. And hydrogen bonding is much stronger as compared to dipole-dipole interaction. So as ammonia has a stronger intermolecular force compared to phosphine, it will have a higher boiling point. And our intermolecular force is hydrogen bonds. Yeah. Now we need to find the formal charge of nitrogen atom in NO3 minus. So we can use the formal charge trick. Nitrogen, if it has one lone pair, it's neutral. If it has more than one lone pair, then it'll have a negative charge. If it has less than one lone pair, it'll have a positive charge. In this nitrogen, there are no lone pairs. There should be one lone pair that's missing, so it should have a positive one charge. And oxygen should have two lone pairs, right? So that's why the oxygen on top, this is neutral. If oxygen has more than two lone pairs, there'll be a negative charge. So there are three lone pairs, there's a negative one charge. Three lone pairs, negative one charge again. Right? So formal charge of nitrogen is +1, option C. Next, we need to find the hybridization of carbon and oxygen in CO3 2 minus. It is a kind of a tricky question. Let's try to draw the Lewis structure. CO3 2 minus looks like this. If you look at the carbon atom, right? Or yeah, in this like around this carbon atom, there are 3 sigma bonds. 1 sigma bond in each of the bonds, right? So 3 sigma bonds around carbon. As you have 3 sigma bonds, what happens is, yeah, your hybridization is the first 3 orbitals sp2, s and 2p. So first we are done with carbon. We know carbon's hybridization is sp2. Now what about oxygen, right? The thing is, here it can form resonance structures. Okay, can have this structure. right? And you can also have this structure. Okay. So oxygen, if you look at into the resonance hybrid, this is a 1/3 bond. Yeah. Every oxygen has two lone pairs and one sigma bond with the carbon. And the third electron is equally shared, right? Or the third, or the pi electrons of the double bond is equally shared amongst all the three bonds, right? So a single oxygen cannot claim ownership of this bond. So around this oxygen, there are two lone pairs and one sigma bond. And we can use this information to find the hybridization. Two lone pairs, one sigma bond, right? That means you'll choose the first three orbitals, s and p and 2p. So sp2 again. So answer would be B. Right. Let's move on to the next one. Which answer shows the correct order of metallic bond strength from strongest to weakest? For metallic bond strength, you need two things. First, you need the charge. Okay. The greater cationic charge means stronger metallic bond. This should be your first criteria, right? Second criteria would be smaller size of cation or smaller ionic size. If you look into the elements listed here, Al forms Al3 plus, Mg forms Mg2 plus, Na forms Na plus, K forms K plus. So aluminium and magnesium should have the highest metallic bond strength. Yeah. So we can eliminate C and D. And then sodium and potassium. Between sodium and potassium, sodium belongs to the third period, and potassium belongs to the fourth period. So you're going down the group, right? From sodium to potassium. Potassium has one extra shell. So potassium is a bigger ion. K plus is a bigger ion compared to Na plus. So Na plus should have a stronger metallic bond strength. Answer should be A. Next, we have to identify which of these elements is in the F block of periodic table. So I have already identified the elements here. So if you check here, you just have to look into the periodic table and you'll find Lu is there at the bottom, right? And so these are F block elements. So your answer would be Lu. Next, you have to find the electronic configuration of an atom of copper. For copper, the electronic configuration should be 4s to 3d9. But copper has an exceptional electronic configuration. So 1s electron goes into the 3D electron, the 3D subshell. You get 4s1 3d10, which is option D. Next, which pair of elements would react with each other least vigorously? So we are comparing group 1 and group 17. For group 1, reactivity increases down the group. It increases down the group because as you go down the group, the electrons will be held less strongly, right? So those electrons can easily leave your atom, and that atom will have a good amount of reactivity, right? So for group 1, lithium is the least reactive. For group 17, reactivity decreases down the group. Why so? Because if you go down group 17, it's iodine, right? If you want to add an electron to iodine, the electron will be placed like at a much higher distance from the nucleus as compared to fluorine. If you're adding an electron to fluorine, this added electron will be much closer to the nucleus. So the nucleus will be able to hold this electron strongly. But in iodine, as the atomic size is pretty big, if you add an electron, this electron, like the nucleus will have a hard time holding on to this electron, right? So iodine is the least reactive in group 17. So yeah, if you mix lithium and iodine, they would react least vigorously because both of them are the least reactive in their specific groups. Answer would be B. Next, which compounds contain an atom in +3 oxidation state? Again, take nitrogen as X. Oxygen generally has a -2 oxidation state, right? you will get X as 4 minus 1, which is plus 3. FeCl3, take Fe as X. Fluorine is a halogen, right? So generally halogen has a negative 1 oxidation state. Only exception is when it's bonded to something more electronegative. 3 times minus 1. X minus 3 is 0. X is plus 3. 1, 2, done. Next is BrF3. Yeah. So take Br as X because fluorine is more electronegative than Br. Fluorine is the most electronegative element in the periodic table. So fluorine definitely will have a minus 1 oxidation state. Okay. So X minus 3 again is 0. So you get X as plus 3. The BrF3 is an interhalogen compound. Fluorine is more electronegative than Br. So, or you know that in the entire periodic table, fluorine will always have a negative 1 oxidation state. The only exception is in F2. So we found that in all these three compounds, we have an atom with a plus 3 oxidation state. So answer would be D. Now, moving on to question 16. Which statement currently explains the violet color of the complex compound CuNH3 whole 4 H2O whole twice 2 plus when copper 2 sulfate reacts with excess ammonia? Right. Now, for complex compounds, there's a thing. The color which we observe is actually the opposite to the color which is, I mean, like the color which we can see, right? So why we can see violet, right? The color opposite to violet in the color wheel has been absorbed. That's why we only see violet, right? So let's find the color wheel here. Yeah, here you go. So violet is here. Opposite to violet is yellow. So that means yellow light has been absorbed. Okay. Now looking at the logic, so there are two things. Either yellow light is released, or of course yellow light is absorbed, and yellow light is absorbed when electrons move from lower to higher energy levels, right? So yellow light is absorbed, that means energy is absorbed. When energy is absorbed, electrons get excited, that is, they get promoted to higher levels. Answer is option D. Now 17. Which functional groups are present in both of these molecules? Let's keep identifying the functional groups. This is fluoro. This is benzene. This is cyano. This is again a benzene group. This is ether, or we call it the alkoxy group. This is amino group, basically a tertiary amine, right? Now, I don't think we have any more groups in the first one. Let's look into the second one. This thing, right, along with this oxygen together is an amido group or an amide group, right? This thing here is amino. Wait, what? Just a minute. I think my pencil ran out of charge. Yeah. All right. So this is the amino group. Okay. This is also an amino group. And this is a benzene ring. So I see amino and benzene common in these two molecules, right? So amino benzene ring, answer is option D. Okay. What is the identity of the alcohol with the molecular formula C4H9OH and which has 4 peaks? 4 peaks means it should have 4 different hydrogen environments. If you do butane 1-ol, how many different hydrogens are there? 1, 2, 3, 4, 5. You have 5 hydrogen environments, not 4. So has to be rejected. Butane 2-ol now. So 1, 2, 3, 4, 5. Again, 5 different hydrogen environments rejected. 2-methyl propan 1-ol. Yeah. This is 1-ol. And you have 2 methyl groups here. This is propan 1-ol, right? Now these two hydrogens, the CH3s, they are in the same hydrogen environment because they are connected to the same carbon, right? So 1, 2, 3, 4. We have 4 hydrogen environments here. If you look into the ratios, there are 6 hydrogen atoms in one environment, that is these 6, right? Then you have 2 in this one, and then 1 here, 1 here. So 6 is to 2 is to 1 is to 1. Exactly matches with the ratio of the peaks. So answer should be option C. Next, how many chiral centers are there in the following molecules? Now, this is also a pretty simple question. Now, this carbon cannot be chiral because 2 hydrogens are attached to it. This one, however, is chiral because you have 1 hydrogen, 1 OH. This is the third group and this is the fourth group. So 4 different groups are attached to this carbon. So this is a chiral carbon. Similarly, for this carbon, it's also chiral because 4 different groups are connected. These two are different. OH and hydrogen are different. Same for this one. You have hydrogen, you have OH, you have this group and this group, which are different. So 4 different groups. That's why it's chiral. This cannot be chiral, this carbon, because it's an sp2 carbon. If a carbon is chiral, it has to be sp3. So that means this carbon should form 4 bonds. Yeah. And for the last one, this carbon has 2 hydrogens attached to it. Again, cannot be chiral. So there are 3 chiral carbons in this compound. So answer should be B. Which statement about an exothermic reaction is correct? So for an exothermic reaction, heat is lost to the surroundings. So surroundings absorb heat. If surroundings absorb heat, what happens is temperature of the surroundings or temperature of the container increases. We can already eliminate A and B. Now, heat is lost to surroundings. That means what? Like heat from the reactants is lost to the surroundings. So reactants have more energy compared to products. Right? So so the other way is products have lower energy compared to reactants, which exactly corresponds to option D. Temperature increases, products have lower enthalpy or lower energy compared to reactants. Next is a calorimetry question. Energy from burning 0.321 grams of methanol caused the temperature of 200 centimeter cube of water to rise by 5 kelvins. What is the enthalpy of combustion of methanol in kilojoules per mole? Let's find the heat absorbed by water, which is mc delta T. Mass of water, so volume is 200 centimeter cube, right? Water has a density of 1 gram per centimeter cube. That means 1 centimeter cube of water weighs 1 gram. So 200 centimeter cube of water should weigh 200 grams, right? So mass of water is 200, C is 4.18, and delta T, change in temperature, will be 5. So if I simplify this, I'll get 4180 joules. This is the heat absorbed by water when 0.321 grams of methanol is burnt. We'll find the moles of methanol, which is 0.321 divided by 32.05. You get around 0.01 moles of methanol. Now enthalpy will be negative Q over N. Negative 4180 divided by 0.01 unit will be joules per mole. Get negative 418123 joules per mole divided by 1000. You get negative 418 kilojoules per mole. So answer is around option A, which is the closest. So yeah, let's move on to the next one. So we are given the Born-Haber cycle. We have to identify which one is electron affinity of chlorine. Let's try to identify all of them. The first delta H1, sodium plus chlorine in their standard states forms 1 mole of NaCl. So this is enthalpy of formation for NaCl, right? This is enthalpy of atomization for sodium. This is half bond enthalpy of Cl2. Half of the Cl-Cl bond enthalpy, right? NaCl2 ions in gas phase, this is lattice enthalpy. Sodium to Na plus, this is ionization energy of sodium. the first ionization energy of sodium. And delta H4 is the electron affinity of chlorine, energy released when chlorine absorbs an electron. So answer is option C. Next, in which reaction does entropy decrease? Right? Solid to aqueous. Guess what? In aqueous, your randomness is more because ions can freely move around. If KBr is in solid, ions are fixed into its place. So randomness is more in aqueous. So entropy increases in part A. Next, NH3 gas, HCl gas forms NH4Cl gas. Two gases are combining to form a solid, so entropy decreases because gases have more randomness compared to solids and liquids. Gas is getting converted to a solid, obviously the entropy decreases or randomness decreases. Answer is option B. Next, what are the signs of delta H and delta S for a reaction that is non-spontaneous at low temperature but spontaneous at high temperature? Use the delta G formula. Delta H minus T delta S. Okay. If delta H is positive and delta S is negative, then guess what? It will be positive, negative, negative. So the negative, negative will become positive, right? So whatever the value of delta H and delta S is, delta G will always be positive. So the reaction is always spontaneous at low time. I mean, always non-spontaneous, low, either low or high temperature, doesn't matter. So first one is always non-spontaneous. We have to reject this. Next one, when both are negative. The delta H is negative, and this thing, like if I just use the absolute values, delta H plus T delta S, right? Because negative of delta S, like negative, negative cancels out, you get positive. So basically, at low temperature, right? At low temperature, delta T delta S, this will be small. At low temperature, delta G will be negative, reaction is spontaneous. But at high temperature, T delta S will be big. So negative H plus T delta S, this entire thing will become positive. So here at low temperature, it's spontaneous, non-spontaneous at high temperature, which is exactly opposite to the logic that is given in the question. So rejected. Now the next one. If delta H and delta S both are positive, yeah, if both are positive, then exactly we'll have this equation, right? At low temperature, your delta H will be bigger than this T delta S. So overall delta G will be positive and the reaction is non-spontaneous. And at high temperature, your delta H will be smaller than T delta S, right? So the negative term is bigger. So delta G becomes negative overall, right? And as a result, the reaction is spontaneous at high temperature. Answer will be option C. Next. Which process to produce ethanol has an atom economy of 100? For this, we should not produce any byproducts. There should only be one product, that is ethanol, which occurs in option A. You don't even have to use the formula of atom economy in these questions. Yeah. Next, which apparatus can be used to monitor the progress of the reaction? pH meter, yes, because it's a neutralization reaction. Yeah, so pH will change. Gas syringe, yes, because CO2 gas is produced. Colorimeter, no, because there is literally no color change. NaCO3, HCl, NaCl, H2O, CO2, everything is colorless, so there is no color change. Answer would be 1 and 2 only, which is option A. Next, compounds P and Q are mixed together, various concentration initial rate of each reaction was measured. We find the order of reaction with respect to P and Q. So, um, I always look for multiples, right? So if you look at 2 and 1, if you multiply the concentration of P with 2 of reaction of experiment 2, then yeah, you get 0.2. And then if you look at the rate, what happens? 0.25 becomes 0.5. So this also got multiplied by 2. So rate is directly proportional to P to the power 1. So order with respect to P is 1. Eliminate option C. Now order with respect to Q. So this you have to compare 1 and 3 now because there only you can find a change in Q. P is unchanged between 1 and 3, 0.2, 0.2. For Q, you have doubled Q. When you double Q, you see this thing also gets doubled, 0.5 to 1. So rate is also directly proportional to Q to the power 1. So order with respect to Q is also 1. So order with respect to P is 1, Q is also 1. Answer is A. Next. What are the units for rate constant of K in the following expression? So rate equals K times concentration of X squared, concentration of Y to the power of 0. So it's easy. Unit of rate is mole dm to the power minus 3 S to the power minus 1. Right? This is K times concentration is mole dm to the power minus 3. So just have to simplify. The unit of K will be mole dm to the power minus 3 s to the power minus 1 divided by mole squared dm to the power of minus 6. Mole gone. This will become dm cubed, right? No, this will become dm cubed on top. So mole to the power minus 1 dm cubed s to the power minus 1, which corresponds to option C. Yeah. Next, which statement about this equilibrium reaction is correct? Removing water has no effect on position of equilibrium. No, if you remove water, equilibrium will try to produce water, so position of equilibrium will change. Next, adding ethanol to the reaction mixture moves the position to the left. If you add more ethanol, right, the reaction will try to decrease ethanol. It will favor the forward reaction, so more products will be formed. So position of equilibrium shifts to the right, not left. Removing ethanol from the reaction mixture moves the position of equilibrium to the left. If you remove ethanol, if this goes down, reaction will prioritize the reverse, the equilibrium will prioritize the reverse reaction. The more reactants are formed and equilibrium shifts to the left, which is absolutely correct. Answer would be option C. Next, how many moles of oxygen are needed for the complete combustion of 11.5 grams of C3H8, which is propane? So, writing the balanced reaction. So you need 3 CO2 and we need 4 H2O directly to balance carbon and hydrogen. Now oxygen here will be 6 plus 4, 10. So I just need to put a 5 in front of O2, right? So moles of C3H8 would be 11.5 divided by 44.1, which should approximately give us 0.261. Then moles of oxygen by moles of C3H8. This ratio would be 5 by 1. So moles of O2 by 0.261 is 5. Moles of O2 would be 5 times 0.261, which finally gives you 1.303, corresponds to option D. Next, we have to find the pH of 0.001 mole per dm cubed HCl. Yep. The concentration of H plus is also 10 to the power minus 3 because HCl dissociates completely, right? So concentration of H plus will also be 10 to the power minus 3, correct? Now pH is minus log base 10 H plus, which is negative of negative 3, gives you 3. C. Next, which solution is acidic at 25 degrees Celsius, right? You just have to find the pH in each of the cases and check where pH is less than 7. For the first one, 10 to the power minus 9. This is the H percent concentration. pH is 9, right? That means it's basic, not acidic. Reject. Next one, pOH will be 13. Yeah. So pH will be 14 minus 13, 1. This is very strongly acidic. Answer should be B. Let's check the other ones. pOH will be 6. pH will be 14 minus 6, which is 8. Then P of H2O plus or pH would be 13, which is again makes the solution basic. Answer would be B for 32. 33. Which equation correctly represents a chemical reaction? So we need a proper chemical reaction in this case. Okay. Now the first reaction looks completely right. It's balanced. Everything looks good in the first reaction. Also, this reaction occurs quite, like obviously it occurs. So probably I'll choose A. Well, let's check the other option. Cu plus twice HCl gives you CaCl2 plus H2. For option B, issue is this reaction does not occur because this copper is less reactive than hydrogen. Copper cannot displace hydrogen from an acid. Yeah, so this does not occur. You can say Cu is less reactive than hydrogen. NaOH plus HCl gives you NaCl plus H2. Wrong, it should be NaCl plus H2O. Last one, twice HCl plus HCO3 whole twice, CaCl2 plus H2O. This is also wrong because they are missing carbon dioxide, right? There should be a plus 2 CO2. So for 33, answer should be A. Next, which of the bases has the strongest conjugate acid? We can find the pKb values and then compare, right? The weakest base will have the strongest conjugate acid. So for NS3 pKb, I can do minus log base 10 Kb on my calculator. I'll get 4.74. For CH3 whole twice NH, pKb would be 3.23. If I check the pKb value, CH3CONH2, this has the highest pKb, so this is the weakest base. If this is the weakest base, guess what? It will form the strongest conjugate acid. So answer would be D. Next, what is the pH of a buffer solution which contains 0.5 mole per dm cube methanoic acid and 0.25 mole per dm cube sodium methanoate? Here's the Henderson equation. pH would be pKa plus log salt by acid 3.75 plus log 0.25, which is the salt concentration, sodium methanoate. Acid concentration is 0.5. So if I simplify this thing will become approximately negative 0.3. So 3.45 should be our answer, which is option B. Next, which the following occurs when tin is added to separate solutions of lead to nitrate and manganese to nitrate. So tin Sn replaces lead, right? So tin is more reactive than lead, okay? But tin cannot replace Mn, so Mn is more reactive than Sn. So if you write the order, Mn stronger than Sn, stronger than Pb. Option C. Next one. What are the products of electrolysis of molten Al2O3? Okay, just draw an electrolysis setup here. These are your batteries. Positive charge, negative charge. So Al will form Al3 plus, and the Al3 plus ions will be attracted towards the negative electrode. O2 minus will be attracted towards the positive electrode. So at the negative electrode, Al3 plus will take 3 electrons to form Al. So as this is reduction, this is the cathode. At cathode, there is always reduction. At anode, there is always oxidation. If this one is the cathode, the other one is anode. In anode, 2O2 minus, they will release their electrons to form oxygen gas. There's some electrons, right? So at cathode, Al will be formed. At anode, oxygen will be formed. Answer is option A. Next, which compound can be reduced to produce butanol? So if you look at the chain, alcohol, aldehyde, carboxylic acid. This is the oxidation chain. The opposite would be the reduction chain. So carboxylic acid can be reduced to form aldehyde. The only carboxylic acid here is butanoic acid. Answer would be A. Next, we shall consider the following electrode potentials, right? Which species will react spontaneously under standard conditions? So Zn and Fe2 plus. For Zn and Fe2 plus, I'll flip the first reaction. Zn gives you Zn2 plus 2 electrons. Fe2 plus 2 electrons gives you Fe. E naught value will be plus 0.76 as I have flipped it. The other one will be minus 0.45. Cancel this out. So yeah, if you look at, I don't need the reaction, I just need the E naught value. E naught value will be 0.76 minus 0.45. This is 0.31. As E naught is positive, this reaction will be spontaneous. Answer would be A. For any spontaneous reaction, your E naught value, right, should be positive. That's it. Now the last question. Which of these ions would be a suitable species to react with benzene in a substitution reaction? Benzene shows an electrophilic substitution reaction. Okay. And if you look into the option NO2 plus, this is used, this is the electrophile in substitute in the nitration reaction of benzene. The answer would be option C. A and D can be directly rejected. B can be rejected because NH4 plus is not a strong electrophile. So for question 40, answer is C. So we are done with this paper. Thank you so much for watching this video. I'll see you all in the next one. Bye bye.